Now you can hear me. Right? How's that? I missed a step. Wow, it's 1:15 already. Sorry. I missed a step. Unbelievable. Okay. Okay, how does this sound? How is the quality of the sound? So I was asking, even though you couldn't hear me, how was the test? So how's the sound? How's the test? Good morning. Sorry, I skipped a step. I missed a step in the setup. Lots of steps. Oh. So I didn't get any complaints about the test. The test was worth 10% of your final grade. I'm going to double check that. I made it 10%. No, I made it 15%. Okay, so it's 15% of your final grade, which is not a lot. So it wasn't tremendously challenging, I have to say, but it was just a good baseline. Now from here, the tests are going to assume the knowledge and we move forward, okay? And we have another test in about a month. Okay? That will be worth 20%, and then the following test will be 25%, and then there'll be a test on everything. All right, so the partial tests, they do depend on the material from before, so you do need to remember everything, really. But I won't directly test old stuff. It's just, it'll be assumed knowledge. All right, so, and I still have to send you the non-marked up notes. I don't know. This transfer to a new computer, I have to give you the original notes. These are the marked up ones from the class I taught last semester. So I will get you those, but in the meantime, let's get back to it. So let me know, how was the test? Oops. Okay, so the test was good? Good. Okay, so I just asked one question, I think, that included interest rate conversion or recognizing that you have to use the correct rate in the calculation. And so I want to get back to this discussion. You do have all the notes, and I gave you also some handouts. And there are more notes and there are more question papers, so I will share those with you for this next week. Okay? For now, let's solve some problems. Okay, let's start with the document 2.6, okay? And then, let's see, have any of you tried document 2.6, review 1? So I have the instructions at the top, but I want to start solving these problems. Let's take this, oops, that's not good. Let's take this problem. All right, so let's look at this together. The other notes I gave you, what I'll do is ask you, okay, work on this. If you, okay, wait. First question is, how many of you have started review 1? Okay, so work on this, and I'll get you those other documents. Okay, I'll give you 5 minutes. So follow the directions. You need to use your timeline, show a timeline, and the formulas and the answer. Okay, 5 minutes. Okay, for people who did it, I will send the second review. Okay, so I just emailed you review 2, so try that if you're bored. So shall we look at this together? Okay, what will $150,000 be worth in 20 years if the annual effective interest rate is 15% for 10 years and then 8% for the remaining 10 years? So there's no interest rate conversions here. So when I read this problem, what I do is I look first to see the timing of payments. That's my first step in reading problems. When you read this problem, there are no payments, right? So you don't have to worry about the timing. What we have is just an accumulation of a lump sum for the first, so it's a differential interest rates, right? So the first 10 years will be 15% and then 8%. So this is just the basic time value of money problem. And didn't even draw the timeline, but okay, so if I drew the timeline, so this is how I would draw it. Just to give you an idea. So for the first 10 years, to the end of 10 years, it's going to be 15% accumulation rate or interest rate. And then for the next 20 years, it's going to be 8%. So that's how I present this. It's going to be 150,000 here. And then this accumulates over this period. And then, so this is easy, right? But the point is you can change the interest rate, and I can do time value of money on top of time value of money. That's the point here. Okay, and I'm going to find this. So this is, I've used TVM twice. The time value of money, the basic formula twice. So in response to this concern about steps, well, there's no timing of payments here. I mean, there's no payments, so that's not relevant here. But still, I ask myself the question, need to get into the habit. So there's no payments and there's no conversions necessary. Okay, so let's try the next one, unless you have any questions. All right, here's the next one. 5 minutes. Just sketch something out, and don't forget to ask yourself the question, what's the timing of payments? And again, the people that are bored, you could be working on review 1 continue that I just sent you. Okay, so how to go? You have the answers again. But let's see, let's lay this out together. Okay, so starting 1 quarter from now, Lydia will begin to deposit $1,000 at the end of each quarter into an account to save for her retirement. She will do this for the next 30 years. All right. Then I have some questions. So let's see. Identify the timing of payments. Step 1. It's always the same. Whether they're payments or not, you got to ask yourself. Get into the habit. So here there are going to be deposits. So that's a payment. That's like a payment, right? Deposits of $1,000. So that's the amount. And when? Each quarter. So that means I need to prepare this answer, or prepare my problem in terms of quarters. So in this one it's quarters. So I need a quarterly rate, and I need, maybe I can make a timeline. Let's see if there's anything else I need. So I need a quarterly rate. That's the main thing. What do I have? Oh, the timing, the number of years too. So 30 years is how many quarters? Okay, so it's going to be, we have to convert all the variables to quarters to use the formulas that I taught you. Okay, so then I don't have to draw this timeline because it's steady, right? But I will, just for people who are still not visualizing this. It's my terrible line, but that'll have to do. So I'm going to, the important thing is 1 period from today she's going to start depositing 1,000. You can make a note here that it's in quarters. And I said 140, I mean 120. Okay. So that's my sketch of the timeline. And she has to use the interest rate of 5%. Aha, but is this the right interest rate? I'm told it's an effective rate. So that means that this rate was for the whole year. But I need the rate for each quarter that's equivalent. Because the deposits are going to be quarterly, the compounding has to match quarterly in order for me to accumulate this properly. So how do I convert from an effective annual rate, because that's what it tells me I have, to an effective quarterly rate? Okay, so we learned something about dividing, right? Do we divide EAR by 4? Or do we raise the factor to 1 over 4? Which one do I do, 1 or 2? Well, you can check. Is it the same? I'll give you a moment. Check if those are the same thing. So the dilemma is this. I have a rate that's stated over the year as though an amount here accumulates at 5% to here. So every dollar invested at 0 will accumulate to 5 cents. That's what's happening with EAR. But I need to use the equivalent rate of that for lump sums that occur over time. And while I'm adding in these lump sums, there's still that pot that's accumulating, right? That fund that's accumulating, and then I'm always adding a little bit more. So how in the world do I put all that together? Well, I have to convert my rate to a quarterly rate. So which way do I do that? Do I divide EAR by 4, or do I raise the factor 1 plus EAR to the power of 1/4? So do I divide the exponent by 4, in other words? Okay, let's see 5 of you vote for this. 1 or 2? Tanya already did. They will not be the same. 1. I have to do some sort of partitioning. I have to do some sort of breaking up or division. But the question is, do I divide the rate by 4, or do I divide the exponent, the factor, the compounding factor, exponent by 4? There's 22 people watching. Well, I think one of those is me. Can you guys vote? 1 or 2? You guys can cheat and look at the answer. Or you can think about this, because it's really important that you understand. Okay, good. Keep going, people. Vote, students. And the key word here is effective. The EAR, I wrote EAR because they say here that you've been given an effective rate. So that's already an effective rate. It's not a simple interest rate. Okay. Okay, that's a good logic one. If you divide by 4, then you're missing the compounding effect at the interest on interest, right? So if you divided by 4, you would be treating this as though it was the simple interest, and it is not. This is what you should have compounded after a year. Anybody else? You should feel more confident about this. 1 or 2? Commit. Pick one. Nobody else wants to vote? Okay, well, let's see. I'm going to erase this. Or maybe I'm going to shrink it. Okay. So look. If this is 0, okay, maybe my timeline is confusing. So if this is 0 to 1, I think my timeline was confusing, so I don't blame you for not responding. Hold on. Because this is not over 120, this is just going to be over 1, right? 1 period. So for over 1 year, $1, for every dollar invested, you earn 5%. But the payments are over quarters. Move that away. Let me make this a little more even looking. Okay. So the question is, what should this rate be in here so that every dollar invested earns 5 cents. It means that this amount should be the same as this amount. Do you agree? So for every dollar, it will earn interest in here and here and here and here, but I have to end up with the same thing. I still want to get the same that I got here. I'm trying to find the equivalent quarterly rate, the quarterly rate equivalent to the annual rate. So what I need to do is equate these and solve for what I want to find. Okay, so you guys know, some people know that I have to do it this way. Just moving this around. I don't like when I lose things. Let's see what I can do. So I need the quarterly rate, and I'm given, or I have, the effective annual rate. The relationship between them is that the quarterly rate is smaller, and 4 of those makes one of these for every dollar invested. So to solve for this one, that's the one I want, I have to take the factor to the power of 1/4. To get the rate, I have to minus 1. If I just want the accumulated amount, I can just leave it like this. All right, so it's 1/4 to the power. So when I go from effective rates to effective rates, I use this approach. I equate these two and solve. So I gave you a document with all of those here, depending on what you want. So if you want the quarterly rate, you equate this with this and solve for the unknown. If you want the monthly rate, you equate this amount with this and you solve for the effective monthly rate. What we did last class was we equated the daily rate with this, and well, we talked about that. Okay? And similarly for bonds that are semi-annually, they're semi-annual payments and you need the semi-annual rate. So this is one of the two things we learned last class. We don't divide. Dividing is when you're converting between effective and stated rates. Okay? That's when you divide. Anything to do with effective rates, you have to do the division in the powers. You have to partition the factor by dividing in the powers. All right, so let's get it. Let's get that rate. So 1.05 to the 1/4 minus 1 is equal to EPR 1/4. Now this is just a notation. You don't have to divide anything. This is just to tell me that you have the quarterly rate. You could also write that in words if this notation bothers you. You could say quarterly rate or something like that. Okay? So let's put this in our calculator. 1.04 to the quarter minus 1. So how do I do that? Oh, I have this one in the... That's not what I want. Okay, so I write 1.05 y to the x, and you could put 4 and flip 4 to get 1/4 equals minus 1. That's how you find the rate. Now you need to store in 1 because you don't want to lose the decimal places. So that's going to be the extra catch. We'll talk about a continuous compounding. It's different. Yeah, something has to happen, yeah. You don't have to add the 1. All right. So we have that number. Let's go back to that again. 0.01227, all right. And you're going to store that in 1. And remember that you don't have, you have it in decimals, not percent. So that's the value. So because it's a long number with many decimal places, I'm just going to use this notation from my formula. And solve. Any questions so far? I think this is the best way to understand what I'm doing. So I'm trying to find the equivalent rate over the quarter that gives me 5. Let's check. Let's check that that's true. Well, of course it's true because that's how I solved it, but if you want to be sure, take this Four of these should be 5 cents on the dollar. So it's not exactly dividing. It's if you divided 5 by 4, you get a different number, right? So if you divide 5% by 4, is what I meant, you get and here, your rate is a little smaller, all right? So here you get it's going to be 1.25%. Here is 1.22%. But this is the one that will give you exactly 5% over 4 periods. And that's what you're trying to get. And that's because of the interest on interest effect that you would lose if you use this number. So you don't divide by 4 if you want this rate if you have to pay money, right? You want the lower rate. And this is the fair rate. This is not fair. If it's the reverse and you're getting paid, you don't want to, it's not fair to offer this rate to people, just dividing by 4. You would have to do this calculation. All right, so let's finish this problem. All we found is the rate. So let's write up the answer. For 120 quarters, $1,000, and we use the EPR. I'm going to add another page. So you all said and done, the future value at 120 quarters is equal to an annuity. This is an annuity of payments of the first payment being 1 period from now is 1,000. Using the quarterly rate, which is a long number, I'm not going to write it all out, and this is all I have to write. And because you've done the calculation elsewhere with the quarterly rate, you can solve for this in your calculator. So I'm going to store that in 1, like I said. I'll multiply by 100, or actually I'll do that after. Okay, so now it's 120 periods. I recall my interest rate, and I multiply by 100 to put it here. Then I say, I don't want PV, right? I want to know the accumulated amount. So I put 0 in PV. I put 1,000 in the payments, and then I ask for the future value, and that's the answer. How's that? So let's see. That's not the future value, right? That's the present value. I gave you the present value formula. The future value would have this extra term
Now you have to do it like that to get the right answer. Can't just use the annual rate. The issue is that every period there's an extra 1,000 that has to be dealt with, and that's only captured using the annuity formula. So some things to review here. We use this rate, we change this to quarters, and we have this extra term because we want the future value, not the present value. It's different in our calculators. In our calculators, it'll give us either or, but we have to add this extra term on our test, right? And move it over. How's that? Any questions? No comments? What's your answer? Do you get my answer? 270, 687, 66. Did I do it right? Did I say that right? I think I got that wrong. 270, 687. Any questions? Is that correct? Okay, 31 years from now, Lydia will begin to make withdrawals from this account. She will make annual withdrawals. So now we're going back to the annual rate for 20 years. What is the maximum amount she can withdraw? And you want to find the payment for 5% effective rate. So what is that? So now this is the withdrawal. So what you have is after 30 years, this amount has accumulated. This is what she has in a fund that she can draw from. Call it pension withdrawals. So this is the fund amount, this is the present value. We want to find the payments she can take out every year at the beginning of the year, or 1 year from today, starting 1 year from the 30th. And I can use the effective annual rate because these are annual withdrawals. And she wants to do this for 30 periods, right? Now I've written EAR, but what's EAR? That was always 5%, so I can actually put that number in. So I'm going to go back to the calculator. I'm going to store this value. I can change it to a positive. And then, let's be clear, 30 years, right? That's what it said. Next, 20 years. Oops, 20. You guys didn't correct me. 20 years of withdrawals. So we're going to put 20 into N, 5 into interest. Payment is what we're trying to find. What the PV we have. So this is PV. And payment is what we want. And we're going to put 0 in FV because that's not what we're interested in. This is the present value. So remember I said this is the present value at 30 years or 120 quarters, either of those. Those are the same thing. And then ask to compute payment. So it's going to be 20 years, 5% interest. PV is recall 1 PV. Payment is what I want. Put 0 into face a value or future value and ask for payment. And that's what I get. Is that correct? Very good. Okay, questions? So it's a little more detailed in the notes, but I think I did it a couple different ways. Okay, so now, if you don't have any questions, If you don't have any questions, let me know. Are there any other problems that you'd like me to do? So which ones confused you? No questions? No comments? Can I move on to the next? I'm not sure what to do. Let me know. Are you awake? Are you there? Are you working? What are you doing? So I'm going to send you those documents that were marked up so you have clean versions. All right, I sent you the documents. Okay, Tanya is asked to look at number 6. So number 6 is related to number 5. Let's look at that together. So let's start here. So I'm going to ask you guys to work on 3 and 4 on your own. Let's look at number 5 and 6. So this corporation is expecting to pay quarterly dividends of $5 per year beginning next quarter and continuing indefinitely. Given the risk inherent, the required expected rate of return for investors is the effective rate, 3%. Okay, so dividends, so again, step 1, always identify timing of payments. Quarterly dividends beginning next quarter and continuing indefinitely, but you're given the effective rate at 3%, right? So this doesn't match. They're supposed to be quarterly. So this is annual and this is quarterly. So the payment timing doesn't match the rate, so I need to convert. So I make a point, I need the effective quarterly rate. But you're given the effective annual rate. So this is the same conversion that we did before. We need to take the effective annual rate and divide it in quarters, but in the powers. I'll just write like this. And that's equal to the quarterly rate. So one trick that you can use is just that, see, this subscript should match the exponent. Okay, so this quarter, so these are all in fractions of a year. This is quarter. So you have to take the year and fraction it or partition it in the powers. So that'll give you the quarterly rate to solve this problem for number 5. So for number 5, it is a perpetuity, and it's going to be the current value using all those assumptions of $5 in one period beginning next quarter, right? And continuing indefinitely over the rate of the quarterly rate because they're quarterly periods. So all I've done is use the regular formulas, but now I'm changing what I is. Okay, I'm changing it, converting it. All right, so that was the simple 5. Now, does that affect 6? Maybe not. Due to a growing economy, investors anticipate that in 2 years, dividends on AXE stock will begin to experience growth that will continue indefinitely. Use the description of AXE in 5. So in other words, take the quarterly rate that you got here What are investors willing to pay for a share of stock? So what you have to do here, this was the regular perpetuity. Because we imagine that a corporation can exist forever, and this is the growing perpetuity formula. So what do you need here? Again, you need your rates as quarters, including the quarterly growth rate. So this is the G, and it's already been given quarterly. If it wasn't given to you quarterly, you would have to convert it. Okay, so this is your G for your formula. And this is going to be your I, the same one from before. Okay, so for number 6, you would write that the value today would be, oh, there's another catch, right? In 2 years, dividends. Oh, okay. So we have to include, okay, so the other catch is that this growth doesn't start right away. So we need to consider the timeline for that. So let's draw that timeline together. All right, so we can do this in quarters. So let's make a note, quarters. And then this would be 1, 2, 3, 1 year. And then that's a little bit confusing. I'll just say year 1. And then 1, 2, 3, and then 8 quarters, or year 2. Okay, so that's the second year, that's the first year, and it goes on forever. Back to the problem, it says it's $5 per share starting next quarter, and then it's going to start growing in 2 years. Okay, so it's $5. All right, so this is how it works. In 2 years, there'll be growth, right? Otherwise, it's $5 every quarter. So what do? We need to put all this together to find the value today. The G starts here. And I have to keep in mind my formula. So if the G starts here, and this is, like if you look back, if you remember for the growing annuity formula, it needs to look like this. It needs to be 0, right? 1, that's C1, and then the second period is when the growth kicks in. So we have to match that. So I need to apply my formula 1 period before the first one, and then the growth kicks in. So that will put me back here. Period 6. And that is the big debate. Is that correct to do? Some people could have done it different and got the same answer as I did, and that's fine too. But these amounts will be considered in an annuity, and these amounts after the perpetuity. That's growing. How's that? Questions? So this is why I told you need to know how to maneuver around the timeline, and you should be able to find values at any point in time, and you should be able to apply the formulas at any point in time. So I'm going to send you a summary of how to solve these problems, a summary sheet, and it will describe that. So always the first step is timing of payments. The second step is to make a timeline. Is to make the timeline and apply the formulas where they fall on the timeline. So I'm going to find the value of this portion, the value of this portion, and then in the third step I combine everything, I move everything around, right? And then the third step, yeah, you adjust them and you sum. Let me go back and see what the 2% was. Oh, it's 0.2%, thank you. Yeah, so it's going to be 0.02. There's an extra 0 there. All right, should I give you some time to do that?
Okay, that's my description. Okay, so what am I going to do? I have to get the annuity here. So that's 6 payments of $5 that goes in here. I don't use this one over here. I use the one over here, that $5 in this annuity, because there's nothing here, right? This is 1 period from now. And I have to, so that's part 1 or part A. Part B is that I have to discount this back to times 0 so I can add these together. So I take the value found here and I discount it back and I sum those to get my answer. So I adjust and sum. Should I give you some time? So I've laid everything out. Let's get the values. So let's go from the beginning. So I need the quarterly rate. The quarterly rate is found by taking 1.03 to the power 1/4, right? So my calculator, (1.03) to the power 4, but flip 4 equals -1 equals and store 1. So that's my stored value with all the decimal places. Okay, so it's like 0.0074 or something. And I don't want to write that out every time, so instead I write this, one EPR 1/4. So again, so now what I'm going to do is these two pieces. First, the annuity piece, where all of these, there's 1, 2, 3, 4, 5, 6, right? And I use this one to go in here because this part, if you can focus in on this part alone, right? This is a growing annuity. 1 period from 6 period is the first one, or growing perpetuity is the first one, and then the growth kicks in, just like this. 1 period from now, from 0, is the first one, and then the growth kicks in. To apply this formula, I have to value 1 period before the first one. So that's the $5. And then, so if you could do it at 7 and then make this be your first one, that's another way to do it, and it's okay. You can do that too. It's just that I did it this way. It shouldn't matter. what did I do in the notes? I think I did it this way because I wanted to stick to the regular formula approach. Let me see the notes. Yeah, I did it the same way. I remembered what I did. Okay, so that's why. So we use the 6 quarter because it's one period before the $5, and then the growth comes, which fits perfectly with our formula for growing perpetuity. All right, should I finish it? You guys have the answers. What I'm going to do then is I'll get this one first. So what I'm going to do is I'm going to start on the bottom with my rate. I'm going to minus the 0.002. I'm going to sum it, or whatever, subtract them. Then I'm going to flip it and multiply by 5 to get this amount. So I take this amount and I minus 0.002, and then I say equals and flip and then multiply by 5. And that is the portion that is the growing perpetuity. So from that period onward, it's worth $923.01 or 1 cent. Okay. So this is going to look a little different than what you have in the notes. So it just seems more, I had to pick a way to do it, so I did it a longer way. So this is 007, right? But I need to store that for use in a bit. So I'll store this in number 2 because the interest rate is in number 1. Then what I want to do is I might as well use that now and discount it 6 periods, right? So what I can do is I could use the time value of money keys and just use this as the future value and discount it 6 quarters. Let's try that. See if you guys can keep up. All right, so this is, I'm going to store that, I said, in 2. And see if I remember, I need 6 periods where the interest rate, I'm going to multiply that by 100 because that is the quarterly rate as a decimal, but I need the percentage for the calculator.
And I'm going to recall number 2 to put that in the present value amount. And there are no payments. I just want to discount this amount back to, oh no, I want to put it in the future value, right? Sorry, so I'm going to recall 2 and I'm going to put that in the future value amount, and I'm going to ask to compute, no, I did something wrong. So 0 in payment, let's start from the beginning. So 6 in N, recall 1 to get the interest rate times 100, put that in interest. And then for PV, I'm going to put nothing for now and 0 in the payment, and I'm going to tell the calculator that this is the amount in the future. Now I ask to compute PV, and this is the value I get. So I'm going to put that 88298 and so on. I'm going to store that in 3. All right, so I'm going to put this in here. Let's see if we remember. Let's practice. So I put this I'm going to put this up here. So this ends up becoming 882 97 something, 977, and I'm going to store that in 3. So I make a note. So I have part B done. Now I just need part A, which is an annuity with that rate. So let's try that. Okay, so the annuity is 5 periods. Is it 5? Go back. Let's count again. I think it's 6. It's $5, but 6 periods, right? 1, 2, 3, 4, 5, 6. So it's 6 in N. I'm going to recall 1 for the interest rate. Remember, I have to multiply by 100 to put it, not in there, no. Recall 1 times 100 equals, and put it in here, interest. Then I want the present value for payments of $5. Future value is 0, and I ask to compute. So that is the value of that annuity, $29.24. I'm going to store that in 4. I should store the positive though, right? Let's see what I have. I have this answer here. I'm going to make this a positive 2. So that's just stored in 3. Recall 4. So part 3 is the 882. Or store 3. And store 4 is the 2923. So let's put this on the document. Okay, so I'm not saying it just, you have to be organized. If you're an organized person, you don't have to be a genius, okay? If you're not an organized person, you gotta be organized. You gotta get organized with your presentation and not lose focus. Make a timeline. So this kind of a problem needs a timeline, you see? Some of the problems don't, but this one definitely does. If you did this differently and got the same answer, just make sure your logic is intact. You can ask me, but that's fine. You can do it a different way. Obviously, you cannot use net present value, right? You could use net present value for this portion,
But this, you have to use the perpetuity here, and you have to know how to discount it. Whether you're discounting at 6 or at 7, that's up to you. It's not wrong. So what's the final answer? I have to find the answer by adding PV0A and PV0B. So I'm going to recall 3 and I'm going to add it to recall 4. And that's it. I make a note. How is that? So you can review this, okay? You have the video. Practice while it's fresh. So 9, 12. 21. 9, 12, 21 is the final answer. Okay, so that's an example of valuing stock using all the assumptions provided in the problem. We can even get a little more challenging by adding a second growth rate, all right? And you'll see problems like that as well. In the text, I think they refer to it as differential growth models, something like that. Okay, let's take a 5-minute break so you can organize the documents I sent you. All right? And we're going to get back with, we're going to look at we're going to look at document 2.5 together. Okay, 5-minute break.
All right, I'm back. Was that 5 minutes? Okay, let's see. Let's get the document 2.5. Okay, so these are the solutions to the questions I've already asked. This is how you deal with bonds. Okay, so bonds are stated annual interest rates, so you need to convert them first to effective. And so that's what I do. That's why I divide, because they are stated rates. They're not effective rates. So I'm converting from stated to effective. So I divide and I use this rate in the annuity formula, remember, because that takes care of the payments. And then the lump sum amount, which is missing on my graph. Let me put that on. And the lump sum amount, which is 1,000, I need to add that in. It went missing. And this is document 2.5 or 2.6? 2.5. Okay, so you have the two parts in the formula. You have the annuity piece, and then you have the lump sum, because you get the bond matures and you get the principal, well, you get the face value back. All right, so practice putting this this problem with conversions in your calculator. And here are the steps. The one takeaway from these problems is that you have this new formula, you can think of it, or relationship, that you have to take the coupon rate divided by 2 as well as the interest rate divided by 2. So let's make a summary statement. Okay, so for coupon bonds, both the coupon rate and the yield to maturity are stated rates, so you convert them dividing by 2. So that's for this case and then this case. So practice those problems. Remembering that in practice, after a bond has been issued after the first sale, they can be resold, and you can, from the market, determine the yield to maturity if people are currently valuing the bond or a bond. Like in this example, let me make this bigger. So in the second question, the value or the price, the market value is given as 1,000. You're told the semi-annual coupons are at 7%. You assume that's a stated rate, and then you're given the yield as a stated rate. Okay, both of those need to be divided by 2. Okay, so this is determined from the market information, and then you can find the time to maturity. You can solve for a different variable in your calculator, and also you have to make a formula to demonstrate that relationship. When you have your final answer, that too will be in the timing of the payments for semi-annual coupons. So you just got to remember the formula will just give you in 6-month periods. All right? I want to talk about mortgages now. So turn to page 3. Page 3. Remember to refresh your screen if it gets blurry. Refresh your page. All right. We're on mortgages. You with me? So mortgages are loans for buying homes. And the rules are different in different places. In Puerto Rico, mortgages have a fixed rate for the term of the mortgage. In other places in Canada, you only get a fixed rate for about 5 years, and then you have to renegotiate. So I'm going to teach you how to do either case, because even in Puerto Rico, you can try and renegotiate a loan, the interest rate or the payments. Okay? So let's see. Okay, so you've negotiated a 25-year, $100,000 mortgage at a rate of 7.4% per year compounded monthly. So this is a stated rate because it says per year and it says monthly. Those are different. So that tells me that this is a stated rate. And I use the notation for stated rate R1/2. And that I start doing that, sorry, 1/12. I start doing that just to differentiate notation, but you can just, you don't have to use my notation. It's just to follow along. So this is R1/2, which is 0.074. But that's not what I need for my formula. I need to convert that to an effective rate. The way you do that is divide. Okay, so we're dividing because when we get a stated rate or a simple interest type interest rate, we can just divide. So if you hear about a mortgage rate, divide that one by 12. Okay, that's basically how it works. Mortgage rates are always mentioned as stated rates or annual periodic rates over months. Well, over the year, but compounding per month. So I have this long number, which I should store. Let's store that in our calculator. Just remember, you stored it as a decimal, so whenever you want to use it in the TVM keys, you're going to have to multiply by 100 first. All right, so what are we going to do? We want to solve for the first question. The first question is, what is the monthly payment? Okay, so it's a loan, and it's an annuity payment that we would make, and we want to find out what's the cash flow, what's the first payment, and then all the rest will be the same, right? So this is the present value, this is the interest rate, which I could just write EPR 112 to get that. And it's going to be for 25 years. So we need to convert everything. Remember, step 1 for all problems, even if it's just a mental check, identify timing of payments. In this case, it's monthly. Convert everything, all variables, to months.
that says variables. Okay, so that means we have the EPR 1/4, and we have 25 times 12 equals 300 months. What else do we need? That's everything, right? And you write this on a test, but then you can enter these values in your calculator. Entering 300 into N, recall 1 times 100 into the interest rate, 100,000 into present value, put a 0 in the future value, and ask for the payment. Now you should be able to solve this algebraically as well, but I'm going to count on you to be able to do that if you need to, okay? So this answers the question. The mortgage is $732.50. Any questions? Can you try that? Okay. So that was easy, right? No questions? Now these are important. These are slightly different. They're easy once you know how to do them, but before that, it's quite mind-boggling how you would solve this. So, how much of the first 3 mortgage payments goes towards principal and interest? Okay, I gave you the table already worked out. I guess 2.4, document 2.4 has the blank. So let's see if I can do this myself. So what you need to know for the any test is you need to reproduce this call. Like I made this table, you should be able to make this table yourself. All right. So let's see. Let's reproduce the table.
There you go. Okay, so let's remember the terms. So we had a mortgage with a monthly rate that we found from 0.074 divided by 12, right? And let me make sure. That's what it said, right? Okay, 0.074 divided by 12. That's what we did. Got that number. Okay, so let's put that here. And what else do we need? It's a $100,000 balance. So let's put that here. So this is the $100,000 balance, and that's the first month. At the beginning of the first month. Is that how the table works? Yeah. Okay. The beginning of the first month. Now, interest is going to be charged during that month. By the end of the month, you have to pay interest on this entire amount. So you have to take 100,000 times this interest rate to find out the interest charges. Let's do that. So I'm going to clear this. I'm going to take 0.074 divide by 12, and I'm going to store that there. Now, $100,000 times the interest rate means, so $616.67. We should round it for the table to dollars and cents. So 616.67. So that's just the interest. That's just the interest. It's a lot, right? Do you have $616.67 to pay interest on anything right now? That's a lot. So at the beginning of a mortgage, mortgage as high as $100,000, that's just the interest that you're responsible for. Part of that is paid by the monthly payment, and then the little bit that's left goes on to the principal. So $732.50 we figured out was the monthly payment. So that leaves what amount here? Right, so it leaves $115.83. So keep in mind, I round. Okay, so if you do this in Excel, you got to be careful about the decimals, because Excel will store all those decimals. You have to tell it to round to 2 decimal places, because in fact, this is how we make payments over the month, right? It's in actual dollars and cents. So those decimals need to be rounded to 2. So all we've paid down is $115. That leaves how much in the balance? Okay, so that leaves $99,884.17. So that will go to the next month, that as your balance, so I'll just recopy. And now you take that and multiply that by the interest rate. So you're going to keep all the decimal places of the interest rate, but you're going to round these figures to 2 cents. Okay, so that means in the second month, this is how much interest you're charged. So it does go down slightly, not much. So as time goes on, you're going to pay less interest because you're going to have less of a balance, and you're going to pay down more of your principal as a result. This number always stays the same, right? Because this is your payment, and so this will change. So this will go down while these ones will go up. Okay, so you're paying more down, and then you subtract that off of the 99,884.17, and this is your remaining balance. Okay, any questions? Should I do one more row, or can I trust you see the pattern? Okay, so that's the amount outstanding at the end of 3 years. All right, so that's what I have here. So if I give you a table like this, you know, you got to do this properly. Your decimals are going to be off. Make sure you round. The only thing you don't round is the rate. Okay, so that's the table. And that's the answer to the question. So interest payments, the amount of interest you pay will go down. The principal reduction will go up. And keeping in mind, it's a lot of interest payments. So what's the total interest that will be paid on a loan? Can we figure that out? Over time. So let's figure that out. If you take the total number of payments and you minus the principal, what remains actually is the interest you paid. So have a look here. I'll take the 300 payments of $732.50, subtract off the principal amount, and in fact, I pay more interest than I do take out the loan, like the value of the loan. And how we reconcile this is interesting. So we do this because in the end, people can argue it's you get equity, or you have an asset as a result of paying a mortgage, right? You actually, at the end of the loan, you will own an asset. So it's not the same as a rental payment where you never see the value or accumulation of value because it's not your asset. So you'd have to trade off what the price of renting is against this interest payments that you end up making in the end. However, when you have a house, so you have the equity, and you also have, you have a place to live, right? So you have to offset it by this next best thing, which would be renting. Better would be just living with your parents forever, but nobody wants to do that, right? If you're going to live independently, this is an option to either rent or buy. And in Puerto Rico, or in the United States, in fact, there's the added advantage that when you buy property, your interest payments are tax deductible. So this expense can lower your taxable income. So all of these over a year can be used to offset your taxable income. So that's an advantage. And that's for your primary residence. Also, in Puerto Rico, if you buy a new property, you don't have to pay property taxes on that new property for 5 years. So there's incentives to buying property. Equity. And there's one more I should mention. This is messy, but okay. Advantages of buying. You got equity in the property. What did I say? Interest is tax deductible. And so you have a value. So the amount that you've paid off would be an asset for you, right? And you can even refinance for the equity that you own in the house to borrow money from that property, posting the property as collateral. So there's value here. So then there's interest tax deductibility. You have a place to stay. And if the housing market appreciates, it's a store of value. So it means if prices are going up across the board in all sectors or all markets, and you've put your money into something that's also going to appreciate in value. So those are some of the considerations or advantages of buying despite this menacing, haunting interest rate payment over time. You know what? I'm not applying this to current day because I don't want to make any recommendations particularly. Maybe in a private conversation I can tell you what I would recommend buying or renting. But you'd have to lay it all out, right? I think when there's uncertainty and you don't have the money and you don't know about
the market, you don't know if you're going to have a job, you don't know if there's uncertainty, renting is probably the better option, because you don't want to have trouble making your payments on your mortgage. That can affect your credit and make it unlikely for you to be able to borrow in the future. So the question was, the only incentive to pay rent would be peace of mind, possibly, if you just don't know the situation and you just haven't made a decision and you don't have money to risk. So yeah, rent while you're waiting to see how, if it's worth it. So these are all the things to consider. So when I first moved here, I didn't know if I was going to stay in Puerto Rico, so I rented for 5 years. And it was a very low rent, and it wasn't the best place, but it was just to bide my time before I decided if I was going to stay. And then once I wasn't completely convinced I was going to stay, but I bought a property because I said I was going to try. So I had the money to risk, so I tried. And the markets at the time, the value of homes had gone down dramatically since the financial market crisis, the global financial market crisis in 2008. The housing market just fell. The values fell in Puerto Rico, in addition, because of the economic crisis that it faced, being unable to pay its creditors. So, sorry, everyone's, I don't know how to stop this. Me and my new computer. I have to turn off all the notifications. I have 3 devices on. Okay, let me send this text. Hold on. It's Bloomberg calling me. All right, so what was I saying? So the value of houses had fallen dramatically, so we were able to get a home for a beautiful home for a very low price. And the price of markets hasn't gone up necessarily since 2016, but the housing market hasn't gone down either, so I'm holding that store of value. Buying can be cheaper than renting in Puerto Rico. There's lots of incentives. Okay. This was the bonus, was having, the tax deductibility is incredible because that does not exist in Canada. The incentives to borrow money in the United States are tremendous compared to Canada. So we can talk about all that another time. Let's go to the next question, number 4. Oh, we're almost done, so let's do this, and then we'll go. I will hover the answer. So you have the answer in front of you, but where does it come from? Let's look at this. So assuming the mortgage rate remains 7.4% for the remaining time of the mortgage. So yes, it's a fixed rate. After you've paid 2/3 of the monthly mortgage payments, what is the amount still remaining to be paid on the mortgage? So how would we figure that out? So now, when I make this timeline, this is in months, right? Because payments are monthly.
Now I want to know what remains after 2/3 are paid. So 2/3 of, whenever you say of, you multiply. 2/3 of 300 means the 200th. So after the 200th payment, so 201. So after the 200th payment, what remains here? That's the question. Okay, so you could imagine making that table that we just made and go up to 200 and see what the balance is. Or you can use your finance skill and remember, let's move this over. And realize that that 732.50, is that what it is, continues, right? So that will continue until 300. So the tip is to use those. Forget about what happened here, because that can get confusing. You know, you could figure out how much you've paid off and subtract it. That's one way. That's one way. Or this approach is to find out what remains. So basically you find the remaining on these payments. So there's 100 payments left, and they're all this amount, so it's really an annuity. And that's what you solve. Got it? And that's what I do here. Okay, so the class is over. I'm going to send you some more notes, some more problems you can work on for next week. Please let me know if you have any questions or if you need meet me in office hours. I'm going to send you that the summary sheet that I mentioned as well. And then next week we can just work on these problems. I'll post something in Connect. I'll post something in Connect, I guess, and give you a couple weeks to finish it, okay? So I'll stay on for 5 minutes if anyone else has any questions. Have a good weekend and a good week. Keep in touch.